Okay, in Module 5, we're going to be talking about exponents. And in particular, this corresponds to your ebook, section 5.1. And we're talking about multiplying and dividing common bases. So let's go through a little bit about exponents. Common bases. Okay, so let's define our exponent here. Definition, and you'll see some base raised to some power n. And that n looks like a superscript. Okay, so it's not next to it, actually a little bit littler. And that's what we call our exponent. And the larger one is what we call our base. And you have seen this already. Basically, the exponent tells you how many times you're multiplying the base by itself. So it says I'm going to multiply it n times. Okay, so this is going to be multiplied n times. Or you have n factors of this number. So if I gave you something like 2 to the 5th, right, 2 is your base. 5 tells you how many times you're going to be multiplying 2 by itself. It's your exponent. So don't get confused. It's not 2 times 5. Okay, it's 2 times 2 times 2 times 2 times 2. So you're multiplying it 5 times. Multiplying the base by itself 5 times. Okay, so if we have like bases, let's go through, meaning we have the same base, multiplying like bases. We have a rule for it. Okay, let's say we have some base b that's raised to the nth power, and we're going to multiply it by b raised to some other number, m power. All we do is we keep the same base, we don't do anything with that base, and we simply add our exponents. Okay, so for example, right, so this is basically our rule here. So for example, if I have q to the 4th times q to the 8th, my q stays the same, and I simply have q to the 4 plus 8, and that gives me q to the 12th. Okay, so then in that case, my base was a variable. But I could have, a number, right? I could have 2 to the 5th times 2 to the 4th. So that's going to be 2 to the 5th times 4. I'm sorry, plus 4. That's going to be 2 to the 5th. I take 5 plus 4, and I get 2 to the 9th. And I can evaluate that out if I multiply 2 by itself 9 times. And in fact, that actually gives me 512. Okay, so let's see, let's do a little bit, something that's a little bit more complicated. I have 5u times 4u squared y to the 8th times 2y to the 8th. Okay, the first thing I'm going to do, if you notice, it's all multiplication going across. So I'm going to gather my coefficients. I have, let's see, I have this 5, this 4, and this 2, right? So I'm going to move those up front. Remember, because multiplication, it's commutative, I can do it in any order. 5 times 4 times 2. And then I'm going to look for my u's. So here I have a u, and here I have a u. Now, if you notice, this first u doesn't have an exponent. It's understood that that's an exponent of 1. Okay, so I'm going to go ahead and write u. Oops, I meant to use black here. I have u to the 1 times u squared. And then I have, what else do I have? I have some y's, right? So y and y. So I have y to the 8th and another y to the 8th. So now I've just moved everything around so that my bases are close together. Okay. Well, this is just a number, right? 5 times 4 is 20, times another 2 gives me 40. My u's, that's the same as u to the 1 plus 2. I remember when they have the same bases, I simply add the exponents. And then I have a y to the 8 plus 8. Okay, so that's going to give me 40 u to the 3rd, y to the 16th. Okay, so now we know what it's like when we're going to multiply like bases. We simply add their exponents. So now if we want to divide like bases, we're going to be subtracting the exponents. So dividing like bases, if I have b to the m divided by b to the n, I'm going to take my exponents and I'm going to subtract them. But I take the exponent in the numerator minus the exponent in the denominator. Okay, so that's all we have to do. Now this is as long as our bases are the same. So let's do a couple of examples. If I say divide y to the 15th divided by y to the 8th, I simply have y. I take my numerator, the exponent in the numerator, and I subtract the exponent in the denominator. 15 minus 8 is 7, so I get y to the 7th. If I say divide 3 to the 12th divided by 3 to the 5th, or 4th, let's just do 4th. Again, my bases are the same. Both of my bases are 3's. So I get 3 to the 12 minus 4, or 3 to the 8th. Right, and again, that means I'm taking 3 and I'm multiplying it by itself 8 times. And then let's do something that's a little bit more involved. If I have u to the 6th, w to the 7th, I'm sorry, let's do w to the 9th. And I'll have u to the 4th over w. Okay, so I have to take a look to see which ones are similar, right? And again, remember when I have, if I don't have an exponent, it's always assumed that that exponent is 1, right? Okay, so which ones have similar bases, right? Well, the u's have a similar base. The u's are the same here, right? And the w's are the same there. So this is going to be the same. I'm just going to take this part here, and that's going to give me u to the 6 minus 4. Remember, I take the exponent in the numerator minus the exponent in the denominator. And this one gives me w to the 9 minus 1. And when I simplify that, I just get u squared, u to the 2, right, times w to the 8th. That's all there is to it.